All right, so what we're looking at here is the Kali Linux desktop. So Kali Linux has quite a few tools, and one of them that it has installed by default is Wireshark. But if we go down and we look at sniffing and spoofing, there are many other tools there, actually. But we'll focus our attention here on Wireshark. So let's click there. So when Wireshark comes up, we have the opportunity to choose a network interface. So I'm going to choose Ethernet 0, which is the interface on which I'll be listening for traffic. And as soon as I choose that, it starts capturing by default. So Wireshark is now actively capturing traffic. So to familiarize yourself with the interface, I'm going to show you the menus. So from File, we can actually import dumps, export. We can mark packets under the Edit menu. So we can make a comment on an individual packet if we wanted to. This would be good for documentation purposes. And from the standpoint of the Edit menu, we can also set up preferences on how we view the data, how we sort the columns, and whether or not we add new columns with new packet information. So you have the flexibility to set this up how you want, so you can view the data in a way that makes sense to what you're looking to accomplish. So we'll remove that. You can also include whichever protocols that you want to monitor. So in the View menu, we can force name resolution, and under the Go menu, we can auto scroll and live capture. Now that's what we're doing right now, is we're auto scrolling during the live capture, and that's a good feature, although it can be a bit overwhelming visually if there's a lot of traffic like we have right now. Now you can also set up capture filters. So capture filters, as the name suggests, will filter out certain data based on rules. So if we only wanted to see IP version 4 traffic, we would enter that rule here. Right now we're essentially capturing all data that's coming across the wire. That's layer 2 information, ARP broadcasts, TCP, UDP, HTTP, you name it. So we're capturing a lot of different type of traffic here. So the statistics menu in Wireshark allows us to parse out certain traffic data. We can see what kind of TCP streaming and UDP streaming is going along the wire, who the top talkers are on the wire. And statistically, we can also check out things like HTTP, TCP stream graphing. Now, if we're monitoring Bluetooth, we can choose Bluetooth, and there's, of course, the obligatory Help menu. So we still have our live streaming process. You can see some ARP broadcasts going on in the background, and on the right-hand side, you see some color-coded, swatches. And what these represent are conversation streams. So let's pick one out here. Let's pick on this dark blue TLS version 1.2 client hello. So this is obviously an SSL or TLS communication, and we can barrel down into it, and of course the information is likely encrypted unless it's a control negotiation packet. And notice that it says the destination IP is Des Moines, Iowa, and that it's Microsoft. And so the reason we're seeing this in the capture is because in the background I'm actually uploading data to Microsoft's OneDrive. Okay, so that makes sense that there was a TLS 1.2 negotiation to securely transfer that data that I'm uploading to OneDrive. But this is what it looks like on the wire as you sniff it from a sniffer's perspective. And you can see that Wireshark is a tool that you can use to get in depth, and we can see every component of the communication. We can break it out. We can even follow conversation streams within Wireshark, and that utilizes some of that color coding on the right-hand side of the screen. So as I mentioned, there are some other tools here. I'm going to go ahead and open the terminal, and just out of curiosity, I'm going to see the IP address that we picked up from the packet sniffing session, the 104.208.28 address, and see if I can do a reverse lookup on that. And sometimes just by virtue of doing a ping, it will do the reverse lookup for us. Now I know that this is one of Microsoft's servers because of the GeoIP identifier from Wireshark, but if it's defined in a reverse lookup zone, it should show up here. And it does not reverse lookup, which means that Microsoft has not set up this IP address in a reverse lookup zone. Not necessarily surprising. There aren't always good or valid reasons to leverage reverse lookup zones, and sometimes it's best to not use them for security purposes when you're a service provider. But it's just interesting to see the type of research that we can do utilizing data from Wireshark.